Most systems don't fail in obvious ways. They fail quietly, often, while looking like they're working perfectly.
If you use generative AI for your work, you've probably felt this. You get an answer, and it looks perfect, but something feels a little off. So you read it again. The language is fluent, the sentences connect in a logical way, the structure is clean, there aren't any obvious mistakes.
And the tone? It's confident. It presents information as if it's a fact. Nothing seems out of place.
And then you see it. Maybe a key detail is missing, or a specific instruction you gave was overlooked. The answer is almost right, and that's what makes this kind of failure so difficult to catch.
Okay, so let's look at this more closely. The problem comes down to a simple difference, the difference between sounding right and actually being right.
We can separate this into two ideas. The first is coherence. The second is grounding. It's possible for a system to be very good at one while failing at the other.
Coherence is about how the answer sounds. Is it well written? Is it structured logically? That's coherence. But here's the key. Coherence has nothing to do with whether the information is actually true.
Grounding, on the other hand, is what connects the AI's answer to the correct information. It's the link to the right data source, or the specific rules you set. Without grounding, a coherent answer just hides the mistake better.
Now, you might think the problem is in the AI's reasoning, but that's usually not the case. The reasoning part only works with the information it's given. The real problem often happens much earlier, before the reasoning even begins.
So, let's focus on that part. How does an AI system choose what information to use? This happens behind the scenes, before it generates any text at all.
The process often starts with something called embeddings. It's a simple idea. To compare the meaning of different texts, the system first turns the words into numbers. Then it looks for similar patterns in those numbers.
And this is important to know. This selection is based only on similarity. At this point, the system isn't checking facts, it's not applying any rules, it's just collecting pieces of information that seem mathematically similar to the question.
Okay, the system has gathered a set of similar-looking information, but it can't use all of it. So now, it has to decide which pieces are the most relevant.
It uses something called a similarity score. This is just a number that measures how close a piece of text is to the original question. The higher the score, the more relevant the system thinks it is.
But a high similarity score doesn't mean the information is correct. It doesn't mean it's up to date. It only means it's close in meaning. And this is the distinction. The system doesn't choose the best information, it chooses the closest. This explains why some mistakes keep happening. Imagine you have an old, incorrect file and a new, correct one. If the old file consistently gets a slightly higher similarity score, the system will keep choosing it. This same error will just keep showing up.
So if we connect all these steps, we start to see the chain. We see how a series of small, logical steps can lead to an answer that's subtly wrong. We can call this the quiet failure chain. First, embeddings determine what information is even considered. Then, a similarity score decides what is closest. Other steps might re-rank those results to decide what finally wins. Only after all that does the system write an answer that sounds coherent but may or may not be properly grounded.
So by the time you see the final answer, the most important choices have already been made. Information has already been filtered out. The system's assumptions are baked in. That's why the output can be so fluent and confident and still miss the mark.
And that brings us back to the main idea. Generative AI systems don't often fail loudly. They fail quietly, one decision at a time. This was a foreview of that quiet failure chain.
Tech Foreview.